Dr. Babasaheb Ambedkar Open University.
Namaskar dear students, I am Dr. Himanshu Patel, working as an assistant professor in School of Computer Science of Dr. Babasaheb Ambedkar Open University. I welcome you all to the course on cross-platform application development using Flutter. I welcome you all to this session on state management in Flutter. As a Flutter developer, we know that building beautiful and responsive interface is only part of what makes an app great. Behind every fluid animation, every button press, every changes in layout, there is a something fundamental at play. That's state. State determines how your app looks, how it behaves, and how it reacts to the user inputs at any given moment. Whether you are incrementing a counter, fetching user data from an API, or changing theme, all of that is driven by state. And to manage these effectively, we use state management. In this lecture, we will dive deep into what state is in Flutter, why managing it matters, and how to choose the right approach depending on your app's complexity. Now, let us look at the learning objective of this module. So, by the end of this video, you will be able to understand what is state in Flutter, define state management and explain its importance, differentiate between local and global state, use the state method effectively for local updates, identify the limitations of set state in more complex apps, explore popular state management tools like Provider, Riverpod, Block, GetX, Redux and MobX. Address key challenges like passing data down the Vigate tree, Vigate rebuilding and state consistency across screens. And finally, choose the right state management approach for your Flutter project. Let's get started. So, what is a state in Flutter? In Flutter, state refers to any piece of data that influences how your app looks or behaves. If that data changes, so does your UI. Now think about a counter. Every time user taps a button, the number increases. That number is a state. State includes everything from user inputs, app settings, fetch data, animations, anything that affect your user interface and might change over time is a state. Flutter uses a declarative user interface approach. That means you don't tell the user interface how to change, you describe what it should look like based on its current state. When the state changes, Flutter rebuilds the user interface to reflect new state. This leads to more reactive and dynamic experience. So, in short, state is the driving force behind your application's user interface. Now, let us try to understand what is state management is. Now that we know that what state is, how do we manage it? State management is the set of techniques we use to control, update and monitor the user data that affect our user interface. Without proper state management, even a simple app can become hard to maintain. With it, your app become predictable, scalable and easy to debug. Now, why we need to manage state in Flutter? So, there are several important reasons for managing state effectively. The first is ensure efficient user interface update. Flutter only rebuilds the part of the user interface that need to change, which keeps your app smooth and responsive. Second, it helps with clean architecture by separating the user interface from business logic. You make your app easier to maintain. Third, it allows you to handle complex interaction like loading data from an API, handling errors, or syncing data across widgets. And finally, it supports advanced features like data persistence and offline access. In short, managing state isn't just helpful. It is essential for building professional, production ready Flutter apps. Now let us try to understand types of states. Flutter state comes in two main types. First is called local or user interface state. This is data that lives in a single widget. It is a short-lived and not shared across widgets. Now let's take example. The current value in a text field or the selected item in drop down is an example of local state. This type of state is often managed using a stateful widget and using set state method. Then we have app state, also called global or shared state. This is data that needs to be shared across multiple widgets like user login info or theme settings. To manage this kind of state, we use more advanced techniques like provider, river pod or block. Now let us understand what is set state. We have already used what is set state in our previous demonstration. So let's talk about Flutter's most basic state management tool called set state. This is a method that comes with every stateful widget. When you call it, Flutter knows something in your widget has changed and it needs to rebuild. Inside the set state callback, you update your variables. Flutter takes care of updating the user interface for you. It is simple and it is powerful. It is great for quick local updates. So, set state we have already used. Now let us try to understand how does set state work. So let us understand what happens step by step. So you change a variable that holds your state, let's say a counter. You call set state with a function that updates that variable. Now Flutter marks the widget as dirty and scheduled a rebuild. During the next frame, the widget's build method runs again and your user interface reflects the new state. It is fast, automatic and intuitive. Now let us understand when to use set state method. So on screen you can see our app, which is my app. There is a my catalog and my cart. So we have two screen or widgets, my catalog and my cart. Inside my catalog, we have my app bar and my list items, right? So whenever user log in, it shows catalog, and whenever some items selected from catalog, it is added to cart, and you can see cart is update, and when we click on cart, we can see the cart. So this is example of user interface update. So whenever users log in, it redirects to catalog where user can select items, and based on item state, my cart is updated. So based on item selected, we can reflect the changes inside my cart. So this is how set state works. So when should you use set state? For simple user interface, update inside a single widget. For handling user interaction like button taps, for managing small self-contained widgets, if your widget doesn't need to share state with others, set state is perfect. Now let us try to understand limitations of set state. Set state is a good, but it is not always perfect. Using set state has some limitations which can lead to performance issues, especially if large widgets tree are rebuilt frequently. Then there may be problem of messy code where your logic and user interface are tangled together, and difficulty in managing app-wide state across multiple screen or widgets. When your app grows, so should your approach to state management. So these are the limitations of set state: performance issue, global state, and messy. Performance issue is that if your app is with large widget tree and it is rebuilt frequently, it is not good to use set state method. We have difficulty in managing app-wide state across multiple screen or widgets, and your logic and user interface are tangled together. So these are the limitations of set state. So now let us try to understand best practices for using set state. The first is minimize the scope. You must minimize the rebuild area, only update what is necessary. Second, keep the callback small, means avoid doing heavy logic inside set state. Then you can batch multiple updates into one set state call. Never call set state inside a build method. And for asynchronous task, always check if the widget is still mounted before calling set state. Now let us try to understand global state management in Flutter. Set state is for single screen. For app-wide state, we move beyond set state. So let us try to understand global state management. Global state management is how we manage data that multiple widgets need access to, like user login status, theme preference, or shopping cart contents. Flutter is reactive, so user interface should automatically reflect global state changes. The right global state change management tool helps ensure efficient updates, predictable behavior, and performance. Now, why is global state management important? With proper global state management, you get efficient user updates without unnecessary rebuilds, better code separation and maintainability. The ability to persist data across app sessions, supports for complex workflow, and asynchronous data. Now, let us look at some of the popular global state management approaches. On screen, you can see Flutter offers several popular tools. Let's take a look. The first you can see on screen is Provider, which is easy to learn, great for small to medium apps. Then there is a Riverpod. Riverpod is a more robust version of Provider with better testability and no reliance on build context. The third one is Block, which focuses on separation of user interface and logic, uses Stream. It is great for large apps with strict architecture. Then there is a GetX, which is a lightweight and fast. It includes routing and dependency injection. Then we have Redux, which is inspired by JavaScript Redux. It is very structured and scalable. And finally, we have MobX, which is reactive and simple. It uses observable and reactions for more automatic user interface updates. Now each has its own pros and cons, and your choice depends on the app's complexity and your team's experience. Now let us try to understand state challenges in Flutter. So managing state comes with few common challenges. First, passing data down the widget tree, which can become tedious without the right tools. Second, rebuilding only what is necessary to keep performance high. Third one is synchronizing state across screens. So everything stays in sync during navigation. Tackling these challenges requires right strategy and sometimes the right tool. Now let us compare each of these strategy choosing the right state management approach. So how do you decide? If your app is simple, go with provider or set state. If it is complex with many interconnected features, look into riverpod, block or redux. If you want a fast and easy solution, GetX may be ideal. If reactivity and observable matters, consider MobX. There is no one size fits all, but understanding the trade-offs help you make the right decision. So let us conclude. So what to wrap things up? State management isn't just a technical concept. It is the foundation of every modern Flutter app. While set state is great for local changes, complex apps demand more powerful tools and Flutter gives you plenty to choose from. Mastering state management will help you build apps that are faster, cleaner and easier to scale. And keep building beautiful, responsive and maintainable app with Flutter. Thank you and happy learning. Namaskar dear students, welcome back. We have just learned various state management techniques provided by Flutter. The very first basic state management technique for single screen is set state. So we have already learned set state in all the demonstration we have taken previously. So let us have quick recall to the set state method. So I have provided one demonstration that demonstrate basic counter app where user can increment or decrement counter and based on counter state user interface is updated. So let us start that demonstration. Now on screen you can see my simple counter app. So here we have display 0 in center of screen and in bottom navigation bar we have 3 buttons: minus, reset and plus. Whenever I click on this plus, it will increment my counter and whenever I decrement this, it will decrement my counter and by clicking on reset, I can reset my counter. So this is a basic app which demonstrate use of set state for managing state. Remember, value of this counter is our state. So whenever this counter variable changes, we must update our user interface. So on clicking plus, minus and reset, we must call set state method, right? So let us understand this code. So here you can see this is a import statement as usual for importing the Flutter material design package. Now here I write down void main function which is entry point for our application and inside run app I have provided counter app. So it launches the counter app widget, right? Now counter app extends stateless widgets and this is my constructor and inside that I have written build method which returns material app and our title is counter app and inside home screen I have set counter home page which is a stateful widget. This entire is a home which is a stateful widget. So inside home I set counter home page as a screen of the app, and here I hides the debug banner, which is generally displayed in top right corner of your app. So using debug show check mode banner set to false, you can hide your debug banner. Now let us look at it counter home page. So here I define one class called counter home page which extends stateful widget. Why stateful widget? Whenever I click on plus, minus or reset, my user interface changes. So that is implemented by counter home page. So it is a stateful widget. So I define class counter home page which extends stateful widgets. Now this is my constructor, and whenever I use stateful widget, I must create state using create state method. So here I specify create state returns these counter home page state. So I must define one class counter home page state which extend state for our counter home page widget, which is a stateful widget. Now remember, initially this value is 0, so I initialize this counter variable to 0. These variable store the current count, which is initially 0. Now I must define one increment method to increment the value of counter. But remember, whenever counter is incremented, we must set state. So inside increment, I call set state method, and I have incremented counter by 1. So now whenever we call this set state method, it calls build method to rebuild the user interface. Similarly, I have written decrement function to decrement the counter, and inside decrement I must call set state method to reflect new state on user interface. So again, whenever decrement is called, it calls set state, and in turns it calls build method. And whenever I call reset, again counter is initialized to 0, but we must set state to new value of counter. So there are 3 functions which are called when this corresponding button is clicked. When I tap this plus button, I must call increment. When I tap this minus button, I must call decrement. And when I call this reset button, I must call reset. And inside every tap, we call set state method to update sets. Now set state will call this build method, which displays new value of counter on screen. So inside build, I return scaffold, which is basic visual layout structure, and inside that I have set this app bar with text simple counter app. So inside app bar we set title and its text is simple counter app. Now inside body we want to display this text in the center. So I use center child widget, and inside that I display text. And what is text? Value of counter. So it is represented by dollar and variable name. So underscore counter represent this value which is initially 0. So this text display in center 0, and its style is, you can see font size is larger. So font size is 48. That's all. Now in bottom navigation bar we want to display 3 buttons. So in bottom navigation bar after text we display bottom navigation bar, and I set padding which size between border and our controls. Then in a row there are 3 buttons. So I use child row and set its main axis alignment to space around. So it sets control with even space between them. So here you can see these buttons are evenly spaced, right? So this is the role of main axis alignment dot space around. Now Here we have 3 children which is of type elevated button. So inside row I specify these 3 children. First is minus, then reset and then plus. So here I define elevated button, and whenever this button is pressed I must call decrement method which sets text, which call this build method and which displays updated value of counter inside text, and its text is minus. Similarly, we have reset button with text as a reset and it calls reset function. And last elevated button is plus button. Whenever it is pressed, it called increment method and its text is plus. So I hope you understand this example. Here we have shown that whenever state changes, we must call our set state method, and which in turn called build method, which updates our user interface. I hope you understand or recall how set state method works. In next lecture, we will explore global state management techniques like river pod, provider and block, which stands for business logic component. I hope you enjoy this demonstration. Thank you and happy learning with Flutter.